Hi guys, today we are going to draw the shear and moment diagram of a simple beam loaded with uniformly distributed load and concentrated load sent to us by Miss Nicolay Rivera of the TIP Manila. But before that, we are going to show first the solution for the support reactions for the sake of those who are taking static course this semester. Okay, so first we are going to examine the beam. Here we call this a simple beam because we have a hinge support and a roller support here at A and at B. And we have the uniformly distributed load here of 11 kilonewton per meter and 12 kilonewton per meter over a 6 meter span. And we have a concentrated load of 11 kilonewton here and 14 kilonewton. Okay, we are going to use the summation of moment at A equal to 0 to solve for the vertical reaction at B. Okay, we write summation of moment at A. Let us make it fast. That will give you 11 times 1 plus this 11 times 3 multiplied by half of 3, 1.5 plus this 114 multiplied by this distance, we have 4, then plus the uniformly distributed of 12 multiplied by 3 multiplied by the distance of 1, 2, 3, 4 plus 0.5, here we have 4.5 meter. That is RA all over the total span of 6. Okay, so RB will give you 46.42 kilometer. Okay, if you are sure that this is accurate or correct, you can use the summation of forces vertical equals to 0 to solve for the remaining reaction at A. But for the sake of discussion, we are going to use summation of moment at B equals 0 to solve for the at A. Summation of moment at B equals 0. Okay, we have 14 multiplied by 2 plus the uniformly distributed of 12 multiplied by 3 multiplied by 1.5 plus 11 multiplied by this distance 5 and uniformly distributed of 11 multiplied by 3 multiplied by this 2 plus 3 plus 1.5 is 4.5 meter all over divided 6, that is RA. And that will give you RA to be 47.58 kilonewton. Okay. So again, if you are sure that this is already correct, then you can skip taking summation moment at B equals 0. Instead, you are going to use summation of forces vertical equals to 0. Or you can check your values for RA and RB by taking summation of forces vertical is 11 plus 33 plus 14 plus 36, that will give you 94. And if you are going to add this one, that will give you also 94 kilonewton. So we are now sure that RA and RB are correct. So we are now ready to draw the shear and moment diagram. .58 and this is 46.42 kilonewton. Okay. So first we are going to draw the horizontal line representing the length of the beam. We have an upward support reaction of 47.58 here, less the area of this portion, that is 11, so that will give you a downward flowing here. 47.58 minus 11 is 36.58. minus a downward force of 11 here, that will be like this, and that will give you 36.58 less 11, that is 25.58 here. And then another area here, downward area of 11 times 2 is 22, that will give you 25.58 less 22, 3.58 here. So we have a trapezoid shape here. Straight line, first degree. And then here we have 12 multiplied by 1. So 3.58 minus 12, that will give you a negative answer here. That will give you 3.58 minus 12, 8.42 negative. Okay. And then we have a 14 kilonewton downward, so that will be again minus 14. That will give you 22.42 straight downward here. Negative 22.42. And then the last portion, we have 12 multiplied by 2, that is 24 less 24, that will give you negative 46.42 here, negative 46.42. Then we have an upward reaction of 46.42, that will make the shape diagram close at 0. Okay, so this is very easy. We notice that we have a point here, the point where the diagram crosses the horizontal line. We call this the point of zero shear. Remember that in our last video we mentioned that at the point of zero shear, the moment is maximum. So this is very important to locate the point of maximum moment. Let us designate this as X. Okay, we are going to solve for this X here using similar triangles. So let's say we have X is to 3.58 is equal to this 1 is to 12. Okay, so this is 1 meter, 1 and 12, that will give you X equals 0.30 meter. So meaning this distance here is 0.30 meter, and we have this as 0.70 meter. Okay? So we now have this value of X. This is very important because later on we are going to solve for this area of this small triangle for the moment diagram. Okay, so we are now ready to draw the moment diagram. Straight line. Negative 46.42. Okay, again we are going to draw the horizontal line showing the span of the beam. Okay, so starting at 0, because at in support we have 0 moment here, we take the area of this trapezoid, that will give you 42.08. This plus this 136.58 multiplied by 1/2, that will give you 42.08. It's a curve. Okay? Second degree curve. And next we have this area. Next area, trapezoid. So this is positive. Positive. Then we are going to add this area. 25.58 plus 3.58 times 2 over 2. That will give you, plus this 142.08, that will give you 71.24 kilonewton meter. Kilonewton meter. Okay? So another area of positive here, small positive area here, we have 3.58 multiplied by 0.30 divided by 2 plus this 71.24 here. So we have this part here again, that will give you 71.78. Meaning, this area plus this area plus this area is 71.78 kilonewton meter. Then next we have this area of triangle here, that is 8.42 multiplied by 0.7 divided by 2. This is a negative area, meaning we are going to subtract this from 71.78. That will give you 68.83 here. And the last area, trapezoid here. Again, this is a negative area. So 68.83 minus this area. We have 22.42 plus 46.42 times 2 divided by 2. That will give you 68.83. So 68.83 minus 68.83 will give you 0, closing the moment diagram at this point. Okay, so these are the important values of the moment. This is our maximum moment. Our maximum moment is 71.78 kilonewton meter at this point of 0 shear. So I hope that this video helps you in drawing the shear and moment diagram of simple beam loaded with uniform load plus concentrated loads. One important thing here is you must locate the point of 0 shear, because that point, it corresponds to the important value in the shear and moment diagram, which is the maximum moment. Okay, for Miss Nicolay Rivera, thank you for sending me this beam. I hope that this will help you in understanding the shear and moment diagram. See you for next video.